Then let us start our today's session. So the objective of today's session will be, we are going to discuss about the Riemann integral application, which is nothing but integral as the limit of sum Then we discuss about fundamental theorem. Later, we take the concept of mean value theorems and problems on that. So this gives the full coverage of Riemann integral. Then we stop discussing about Riemann integral. In the upcoming session, we will start with the new one. Okay? So you please take a note of these things. Then we start our class session. After noting, you please tell. Right. So if you consider the application of the integral, that is, in other words, integration can be called as the limit of sum. So the result with regard to this is, whenever you take a Riemann integrable function f on closure interval ab, and the integration value of f over ab is equivalent to limit n tends to infinity summation r equal to 1 to n h into f of a plus rh, where h is equal to b minus a by n. Please take a note of the result. The proof is out of the box. The idea here is nothing but, whenever you are going to find the sum of the infinite series, then it will be represented as an equivalent integral. If you evaluate the integral, then it is nothing but evaluation of the sum. Okay? Is that clear? If you want to evaluate the sum will be represented as an equivalent integral, and if you know the integration value, it is nothing but the summation value. That was the underlying idea. Fine. So please take a note of this result. Usually, we apply this technique on closure interval 0, 1 for the problems having summation. Let me say, suppose you have a summation of the form limit n tends to infinity summation r is equal to 1 to n 1 by n into f of r by n. It was like that. Now what happens? We take r by n as x, and dx is nothing but 1 by n, and limit and sigma will be replaced with integral 0 to 1. So this whole thing is nothing but integral 0 to 1 f of x dx. So evaluation of this value is equivalent to evaluation of this integral. Please take a note of that. While doing the problems, we will make use of it. So we substitute x in place of r by n, dx in place of 1 by n, and limit and sigma both will be replaced with integral 0 to 1. So this concept is called integral as the limit of sum. Fine. Is it clear to all, or any questions? Right. The other one is, since we are talking about the fundamental theorem, first of all, I want to give the illustrations over these things, then we'll go with the problem solving techniques. The second one is fundamental theorem, and the statement is given as you take a Riemann integrable function on closed AB, and a function phi is primitive of f. In other words, on closed interval AB, phi is primitive of f. Do you know the definition of primitive? Yes or no? The definition of primitive. So primitive is nothing but, let me say, you have taken a function f. The function phi is called primitive of f. If you differentiate phi, you will get f. In other words, phi is called the antiderivative of f, let me say, the integral part. And usually, primitive is not unique. Why? Because if you take x square, the primitive of f phi, if you want to write it as, it will be x cubed by 3. Because if you differentiate this value, you are going to get x square. Accepted? So because phi dash equal to f. And you can define phi also as x cubed by 3 plus k. K is any constant. So if you differentiate phi, then you are going to get f. Phi dash is equal to f is satisfied. Accepted? So whatever the function phi you will take, if you differentiate that, you should get f. Then phi is called primitive of the given function. So usually primitive need not be unique. There may be so many primitives. And we are talking about the fundamental theorem. Fundamental theorem states that you have taken an integrable function on closed AB, and phi is primitive function of f. Then the integration value of f on closed AB is equivalent to phi of b minus phi of a. This is nothing but our regular integration formula, because if I have taken x square, if I asked that integral 1 to 2 x square dx, what is the value? We will do like this. Accepted? This is the thing we will do at +2 level while calculating the integration part. So here x cubed by 3 is nothing but primitive of x square, and you are doing phi of b minus phi of a. Upper limit minus lower limit you are doing. Is this result known to you or not? So this is the statement of fundamental theorem. If we have the integrable function f and phi is primitive of f, then integral a to b f of x dx is nothing but phi of b minus phi of a. So whenever there is a function and if you want to find its integration value, then you should know its primitive. In the primitive, you are substituting the interval endpoints. Upper endpoint minus lower endpoint, you are taking that value, it is nothing but integration value. Clear? So this is the statement of fundamental theorem. Then I want to move with mean value theorems. So can I erase this part? Right. Actually, there are two mean value theorems. I will give the statement one after the other. Suppose you take a continuous function on closed AB. So as per the known result, the function is Riemann integrable on closed AB. Now, there exists a point C in the open interval AB such that integral a to b f of x dx is equivalent to f of c into b minus a. So this formula or this theorem gives the result that always the integration of the function is nothing but a multiple of the length of the interval b minus a into something. B minus a is nothing but length of the interval. So it is called mean value theorem. We are going to make use of this theorem as and when one single function is given in the integral. To evaluate its value, we can make use of it. While proving some of the inequalities, it is mostly useful. Okay? Please take a note of it. Then I will go with the other one. It is called first mean value theorem. Is it derivative of Lagrange's mean value theorem? Here we are not at all finding any derivative, right? So there we are writing that f dash of c is equal to f of b minus f of a by b minus a. That is totally different here. So there is no need to find a connection between that chapter and this chapter. Both are different. The advantage of analysis is while you are considering one chapter, all the concepts and theorems are related to this chapter only. We will make use of the other concept less in number from the other chapters. Right. The first mean value theorem states that suppose on closed interval AB you take two functions. F is a function on closed AB, G is a function on closed AB. Both are Riemann integrable. F comma G are Riemann integrable on closed AB. Now what happens among the two functions? Let us say one function G keeps same sign. It means that throughout the interval, if you calculate g of x, it may be either negative or positive. I mean non-negative or non-positive. Either g of x greater than or equal to 0 or g of x less than or equal to 0. That is the property satisfied by g. Then the theorem states that there exists a real number mu such that mu belongs to infimum and supremum of f such that integral a to b f of x into g of x dx is equal to mu into integral a to b g of x dx. This is the statement of first mean value theorem. This result is very useful while proving the inequalities and evaluation of the integrals. So please take a note of it. So for the first three concepts, these are the illustrations. Now we start doing problems from the first one, that is integral as the limit of sum, that we are going to do. Okay? After noting these results, you please inform. Now the first problem is evaluate limit n tends to infinity e power 3n by n. This is the first problem. Since we have the limit and summation is given, we can make use of integral as the limit of sum. And you need to take one more thing, that limit n tends to infinity 1 by n into this part. You take like that the problem. So the given problem can be written as limit n tends to infinity 1 by n. This summation can be written as summation r is equal to 1 to n e power 3r by n. Accepted? So if you expand the summation, you will get e power 3 by n plus e power 6 by n plus so on plus e power 3n by n. So using the technique, it is equivalent to integral 0 to 1 e power 3x dx. So r by n will be taken as x, 1 by n is nothing but dx, limit and sigma is nothing but integral 0 to 1. So if you have a doubt how limit and sigma will be taken as integral 0 to 1, since you are taking r by n is equal to x, here r assumes the values from 1 to n. If you put r is equal to 1, then you have 1 by n is equal to x. Since you are taking limit n tends to infinity, therefore as n tends to infinity, x tends to 0. Similarly, r by n takes the value n, so you will have x is equal to 1. So as n tends to infinity, x tends to 1. So limit and sigma will be replaced as integral 0 to 1 here. R by n is taken as x and 1 by n is nothing but dx. Okay? Is it clear to you? Fine. Any more questions for anybody in the conversion of summation into integral? Please tell. Is it okay to all? Right? Now here, straight away, we don't do the integration here. Actually, what we will do, at this step, we simply write that e power 3x by 3 between the limits 0 to 1. Now the question arises that how you can straight away take in that this value is equal to e power 3x by 3 from 0 to 1 the limits, because here you are making use of the fundamental theorem. So what you will write, the interval is 0 comma 1, the function f of x is equal to e power 3x, define phi from closure interval 0 1 to r by phi of x is equal to e power 3x by 3. Therefore, phi dash is equal to f Therefore, phi is a primitive of f. Therefore, by fundamental theorem of integral calculus, integral 0 to 1, f of x dx is equal to phi of 1 minus phi of 0. Actually, this part you need to write it on paper in the exam. At plus 2 level, straight away we will write that integral 0 to 1 e power 3x is nothing but e power 3x by 3 between the limits 0 to 1. But how this came? It came because of this condition. Okay? So please take a note of it. So if you apply the limits, you are going to get it as 1 by 3 into e power 3 minus 1. That was the solution. Here the question is given as limit n tends to infinity summation r is equal to 1 to n by n square plus r square. This is the problem given to us. Evaluate. So, first of all, we need to convert the expression in the given form, which is integral as a limit of sum. So, in the summation, we should have r by n and we should have 1 by n, because whenever r by n is there, then we write x in place of r by n. Whenever 1 by n is there, we write dx in place of that, and limit and sigma will be replaced with respective limits. So, to make that choice, it is written as limit n tends to infinity summation r is equal to 1 to n. If you common n square here, it will be 1 by n into 1 by 1 plus r by n whole square. Accepted? Right. So this is equal to, doing that conversion, it is nothing but integral 0 to 1 by 1 plus x square dx. And whatever the integration, it is nothing but tan inverse x from 0 to 1. So nothing but tan inverse 1 minus tan inverse 0. So tan inverse 1 is nothing but pi by 4. This is nothing but 0. So the answer is pi by 4. Now what happens? Up to writing this part, before this tan inverse x varying the limits 0 to 1, you should write the writing part as per the previous problem. So f of x is equal to 1 by 1 plus x square. It is Riemann integrable. Define phi as tan inverse x. Then phi dash is equal to f. Phi is primitive of f. By fundamental theorem, integral a to b, f is equal to phi of b minus phi of a. That part you should mention in that box area. So you should not write straight away, this is equal to tan inverse x from 0 to 1. Please understand, whenever you are solving a question by means of Riemann integral, at this part you need to mention that writing part as per the box provided. Okay? So the answer is pi by 4 here. Is it clear to all? Fine. Then I am going to the other one. Because this concept is important, we have so many problems on this model. So the other problem is limit n tends to infinity 1 by n plus n square by n plus 1 whole cube plus n square by n plus 2 whole cube plus so on plus the last value is 1 by a10. So this part we are going to evaluate. So first of all, we are going to represent the summation in the required form. So this is equivalent to limit n tends to infinity. First part can be written as n square by n cube. Here n square by n plus 1 whole cube plus so on plus n square by n plus n whole cube. Accepted all? The conversion of the summation in the required form. Right. Now let us use the sigma notation here. This is equal to limit n tends to infinity. Summation r is equal to 1 to n. Summation, you can say r is equal to 0 to n. I can say, yes, r is equal to 0 to n, you can take n square by n plus r whole cube. So by taking n cube as common here, so if you replace the respective ones, it will be integral 0 to 1 by 1 plus x whole cube dx. Accepted? Please check on the conversion. However, if you have a doubt, then you can say that replace r by n with x, 1 by n with dx, limit n tends to infinity sigma with integral 0 to 1. As a rougher, you can mention like that. Or simply, you can provide a since integral as a limit of sum. Because here, what is the function you are taking? 1 plus r by n, right? Yes or no? So if you take the limits, r takes the 0 value there, then what will be x we are going to take? Right? Does it make a difference there if you write like that? I think it won't. Right. However, if you have a doubt with regard to 0, then what happens? Since limit n tends to infinity is applicable to this entire portion, here we are just finding the summation value. So this whole summation will be treated as limit 1 by n plus limit of this portion. So limit 1 by n is 0. From this onwards, you can write that summation r is equal to 1 to n square by n plus r whole cube. That won't make it change. You can write that. You can write like that also. Accepted? That you can write like that. So for the first part, the limit value is 0. For the rest of the part, summation r is equal to 1 to n is applicable if you have a doubt. So integral 0 to 1 by 1 plus x whole cube. So if you go for the regular integration, it will be equal to minus 1 by 2 into 1 plus x whole square between the limits 0 to 1. So can you apply the limits and give me the value? What it will be? applying upper limit minus lower limit. I think you may get the value as 3 by 8. I hope so. Please check on the limit part. Yeah. Then on this concept of integral as a limit of sum, I want to take 2 more problems, then I will conclude the discussion. Because this concept is useful, we have some related problems in the previous year chapters and UPSC questions. Right? Can I erase this problem? The solution? Okay. Now the other question is, you are going to evaluate limit n tends to infinity n power n by n factorial whole power 1 by n. This thing we are going to evaluate. I think it is one of the previous year questions of UPSC. I hope so, this problem. Right? So what happens, since you are going to evaluate this value, let us take that the evaluation value is nothing but L. Now, it is nothing but limit n tends to infinity. Since n is applied n times, multiplied, so n into so on n by 1 into 2 into so on 3 into n whole power 1 by n is equal to L, because n factorial is nothing but n into n minus 1 into so on into 1. So if you apply logarithm on both sides, then you have logarithm L is equals to limit n tends to infinity, the power value comes to the front, and the product will be treated as the summation. So you have log n by 1 plus log n by 2 plus so on plus log n by n. Accepted? Any questions? So the summation will be used under sigma notation. Limit n tends to infinity 1 by n, summation r is equal to 1 to n log n by r. So also write it as limit n tends to infinity 1 by n, summation r is equal to 1 to n log 1 by r by n. Accepted? The simplification part. So using the notation, the conversion is nothing but integral 0 to 1 log 1 by x dx. So it is equivalent to minus integral 0 to 1 log x dx. Any questions on this? Say. So if you calculate integral log x, it is nothing but x log x minus x. So between the limits 0 to 1 you are going to apply. I think you are going to get the value as 1. So log L is equal to 1, therefore L is equal to E. So the answer of this part is nothing but E. Please check on that. If you have any question, you can ask how the changes happened. Is that clear or any doubts? So please take a note of this. After noting, you please inform. Actually, we always take 10 because log to the base 10 you will take. But in general, we always take the scientific logarithm, right? That is base 2. That's why I have written E. Always, otherwise the value will be 10. I go with your words. Accepted? Yes, we have to go with E. Because if you have done experiment with regard to this problem and you have fed the same result, limit n tends to infinity n power n by n factorial whole power 1 by n for a computer, it gives E, not 10, because it takes the logarithm under base 2, not on base 10, isn't it? So in that sense, I have taken the value as E apart from 10. So while applying the limits, since 0 into anything is 0, so here while applying the limits 0 into log 0, since log 0 is undefined, so 0 into anything is 0 is taken like this. While applying the limits, you have a doubt. I agree. 0 into anything will give us 0. Right. So let me take one more problem on this concept. I think it is also a previous year question. Just hold on a moment, I will go for it. Just give me a little moment. Yeah. The problem is given as limit n tends to infinity, right? 1 plus 1 by n into 1 plus 2 by n into so on, 1 plus 4n by n whole power 1 by n. And the solution is also given that prove that this value is equivalent to five into 5 by e whole power 4. Please take a note of the problem. Is it noted? So let us take that this entire value is equivalent to L. Now let us take logarithm on both sides. So you have log L is equal to limit n tends to infinity 1 by n into log of 1 plus 1 by n plus log of 1 plus 2 by n plus so on plus log of 1 plus 4n by n. So using the summation, it will be limit n tends to infinity, summation r is equal to 1 to 4n log of 1 plus r by n. Please check. So if you convert the summation part, it is equal to integral 0 to 4 log of 1 plus x dx. Because earlier we take the summation as summation r is equal to 1 to n. Here the summation is varying from 1 to 4n. So apart from integral 0 to 1, we will take integral 0 to 4 here. That was the modification here. Is it okay? Right. Now we are going to do the integration by using the integration techniques. Yes, 1 by n also will come. I failed to note, place it here. Yeah. So if you do the integration, I will say it will be coming as log of 1 plus x into x, and into this will be 1 by 1 plus x dx. And this value is equals to 4 into log 5 minus, so adding and subtracting 1 in the numerator, you will get the value as and since it is minus of, here you will get plus. So simplifying the terms there, you will get it as 4 log 5 minus 4 plus log 5. So this is equivalent to 5 log 5 minus 4. And how to simplify that value? And it will be written as log 5 power 5 and to evaluate the given value, it will be pi power 5 minus log e power 4. Pi by e whole power 4. or simply if you skip this part, that we will get. That was the answer. So please check for the simplification part once, how it is done. Any more questions for the simplification part? To anyone? If everyone is clear with this, then I want to take the problems on mean value theorems. So do you need any other practice over this integral as a limit of sum? Anyone? Or is this sufficient? I think this problem and the previous one are given earlier in UPSC. I hope so. Right? So can I erase this part? So just recollect the concept of the mean value theorem, which is given earlier. Then I want to give an inequality. Then we will discuss why we are going to make use of the mean value theorem here only. That's the key. Fine. Now the problem is given by, show that 1/4 is less than integral 0 to 1/4 dx by root of 1 minus x square, and which is less than 1 by root 15. So please take a note of that. And usually whenever there is an inequality, we will make use of Lagrange's mean value theorem earlier. There it won't contain any integral symbol. We just have inequality involving some functions. So you have a function which is less than some value and which is less than some value. So in such cases, by making use of Lagrange's mean value theorem, we are going to deduce the inequality. Can you remember that procedure while doing mean value theorems under derivative chapter? Now what happens, it is also an inequality which is involving the integration symbol. Since the symbol of integration is involved here, we need to understand that the question is taken from the integrability chapter. And again the question arises that to prove the inequalities we have two techniques. One is mean value theorem, another one is first mean value theorem involving two functions. So here there is only one function usually, that is 1 by root 1 minus x square. So I am going to make use of the mean value theorem which is stated earlier, and the condition seems to be integral a to b f of x dx is equal to f of c into b minus a. This is the condition of the theorem. Now what happens to apply this condition or the result? What is the criteria? F must be a continuous function. Then only you are going to write integral a to b f of x dx is equal to f of c into b minus a. So if you observe that the function is nothing but f of x is equal to 1 by root 1 minus x square, and the interval is nothing but closed interval 0 comma 1 by 4. Now how to prove that it is continuous on the given interval? Now what happens? We simply don't do any procedure, we simply go for the writing part. It is the writing we write in the examination paper. So we know that 1 minus x square is a polynomial. It is continuous on the number system R. Hence it is continuous on closure interval 0 comma 1 by 4. Because 1 minus x square is nothing but a polynomial, hence it is always continuous. Because it won't go undefined at any real number. Accepted? Yes or no? Right. So therefore root 1 minus x square is continuous on closure interval 0 comma 1 by 4, and in particular its value is greater than 0, it is positive on the given interval. As we know, if f is continuous, its reciprocal 1 by f is also continuous. Since the value is not equal to 0, root of 1 minus x square on the given interval, so 1 by root of 1 minus x square is also continuous on closure interval 0 comma 1 by 4. So the function is continuous on the given interval, hence we can apply the mean value theorem. So these sentences we will write on paper. There is no need to prove by the calculation of left hand limit, right hand limit, etc., etc. We simply write on paper. Okay? Any questions to anyone? So if we take the derivative of this mean value theorem expression, we get Lagrange's mean value theorem expression. So that's why you thought that there might be some connection between the two. Of course. So you are going to take the derivative of these two. So you are saying that if I take derivative, integration and derivation gets cancelled. So you will get 0 is less than 1 by root 1 minus x square is less than 0. Just like an expression like that, say. You are saying that for that inequality, if you apply the derivative, this mean value theorem expression, you are going to get an expression which is connected to the Lagrange's mean value theorem, isn't it? Okay, then we need to think of one thing, that so for mean value theorem, the condition is only for continuity. But for Lagrange's mean value theorem, we are going to check for continuity as well as derivability on the open interval too. So if you generalize this criteria, every continuous function need not be differentiable, isn't it? So we have a chance that maybe you are going to deduce a relation between these two, but you cannot generalize your statement. Because if you want to generalize that, you should have a certainty in giving the answer with an authentication proof. That's why I am not touching that part. Fine. So is this explanation sufficient for proving that this is a continuous function on the given interval 0 comma 1 by 4? The same words we will write on exam. Okay, we don't prove that it is continuous separately. We simply state these words. 1 minus x square is continuous on the real number system. Hence, it is continuous on the given interval. Root of 1 minus x square is continuous on 0, 1 by 4, and it is greater than 0 on this interval. And 1 by root of 1 minus x square is continuous. That's how you can apply mean value theorem. These 4 lines we will write on the paper. Now, coming to the deduction part, the inequality. Therefore, we can say, as per this condition, there exists C belongs to open interval 0, 1 by 4, such that integral 0 to 1 by 4 dx by root of 1 minus x square is equal to f of c into 1 by 4, f of c into b minus a, as we know. And this value is nothing but 1 by 4 into 1 by root of 1 minus c square, because f of x is nothing but 1 by root of 1 minus x square. So this is our first equation obtained from using mean value theorem. But our interest is, we need to get the inequality like 1 by 4 is less than, something is less than this. So we are going to use this criteria. So using the condition of C, you are going for a construction which gives this value in the middle. Now, how the construction takes place? So we have 0 less than, C is less than 1 by 4. Since we have C square, take square on both sides. So 0 less than C square is less than 1 by 16. Minus is there, consider minus. So 0 is greater than, minus C square is greater than minus 1 by 16. You have 1 is there. So 1 greater than 1 minus C square is greater than 1 minus 1 by 16, nothing but 15 by 16. 1 minus 1 by 16, right? You have a square root, take the square root. So 1 is greater than root of 1 minus c square is greater than root 15 by 4. You have a reciprocal, take the reciprocal. So 1 is less than 1 by root of 1 minus c square is less than 4 by root 15. Since 1 by 4 is there, multiply with 1 by 4. Then you have 1 by 4 is less than 1 by 4 into 1 by root 1 minus c square, which is less than 1 by root 15. And in the middle part, you will write that from equation 1, it is nothing but integral 0 to 1 by 4 dx by root 1 minus x square. That's it. So in this way, we will prove the inequality. So equation 1 is obtained from mean value theorem, stating that since it is a function which is continuous, hence we can apply the mean value theorem of Riemann integration. So integral this value is equal to f of c into b minus a. And we go for a construction with regard to the value of c, and in the middle, yeah, exactly we will get this expression. And in place of that, we substitute the integration value. In this way, we will get the integration value. Fine. Is it clear or not? So if everyone is clear with this, please take a note of it. Then I will erase, and I will take one problem on the first mean value theorem involving two functions. Right? Now the problem is prove that 1 by pi less than or equal to integral 0 to 1 sin pi x by 1 plus x square dx is less than or equal to 2 by pi. This is the problem. Obviously, since it involves the symbol integral, so we will have the Riemann integrability concept here, and it involves two functions. One function is sin pi x and another function is 1 by 1 plus x square. So since the integrand contains two functions, we are going to make use of first mean value theorem. And if you look at the statement, the criteria is you should have two functions which are Riemann integrable on closed AB, and one function keeps same sign, and later you should have the condition that integral a to b f of x into g of x dx is equal to mu into integral a to b g of x dx. This is the statement which I have given earlier. Now here one usual question which haunts our mind is, among the two functions, which one will be taken as f and which one will be taken as g. That is up to your choice. You can take any of the functions. But the thing is, if you look at the statement which is given there, in the answer you should have integral a to b g of x dx. So we are going to take a function which is comfortable to integrate as g. And the function which we are doing integration for it, it must keep the same sign. Means it is either greater than or equal to 0 or less than or equal to 0 throughout the interval. So in this connection, I want to take that f is equal to 1 by 1 plus x square, g is equal to sin pi x. That I want to take, because integration of sine is cos, which is very easy to understand, and it is positive, it is greater than or equal to 0 on the given interval. Do you agree? Say. That's why I am going to take f is equal to 1 by 1 plus x square and g is equal to sin pi x on the given interval closed to 0, 1. Now if you look at the statement, f and g both must be Riemann integrable. So how do we say that the two functions are Riemann integrable on the given interval? If they are not Riemann integrable, you cannot make use of this statement. So we say that the function f is monotone. It is a monotonically decreasing function, isn't it? So we write that f is a monotone function. So by known result, f is Riemann integrable. Since the function g is a continuous function, it is Riemann integrable. You can also write like this: f and g both are continuous functions. 1 by 1 plus x square is a continuous function. Sin pi x is a continuous function. Therefore, they are Riemann integrable on the given interval 0, 1. So, the first condition of the statement is satisfied. And g keeps same sign because it is positive throughout the interval. It assumes positive values. You cannot get negative value on the given interval. Therefore, f and g satisfy the criteria of first mean value theorem. Therefore, there exists a value mu which is lying between infimum f and supremum f, such that integration of the two functions is equal to this part. Now here comes the situation. First you are going to evaluate this integral part. So you are going to calculate integral 0 to 1 sin pi x dx. And what is the integration of this one? Minus cos pi x by pi between the limits 0 to 1. And what is the value here? It is nothing but 2 by pi. Accepted? Yes or no? Right. All of you agree? And please understand this. While calculating the integration of integral a to b g of x dx, we always make use of the fundamental theorem. So what does it mean? After writing this integration, we should not write straight away that this is equal to minus cos pi x by pi from 0 to 1. We should not write like this. So at this part, you should mention the box which I have given earlier. So what it is? Take, we have g is equal to sin pi x on closed interval 0, 1. Define phi as minus cos pi x by pi. Therefore, phi dash is equal to g. Phi is a primitive of g. By fundamental theorem, integral 0 to 1 sin pi x dx is equal to phi of 1 minus phi of 0. Therefore, applying the limits, the value is 2 by pi. So in this way, we should mention here. So we should not take the function as it is of the plus 2 level. We should not write like this. So after considering this integral, you should write the writing part in the box. Then straight away you do the integration and the result is 2 by pi. Is it clear to everyone? Please tell. Right. Now, you have mu is left there. What is mu? Mu is a real number which belongs to infimum and supremum in between, or lying between infimum and supremum. So, for the function f, 1 by 1 plus x square, since it is a decreasing function, so on the interval 0, 1, the first one gives supremum, the last one gives infimum. So infimum f is equal to 1 by 1 plus 1 square is nothing but 1 by 2. Supremum f is equal to 1 by 1 plus 0 square, it is equal to 1. Therefore, you have 1 by 2 is less than or equal to mu is less than or equal to 1. Is that okay? Now, in the middle part, mu into something is there, right? This double integration is equal to this, nothing but integral 0 to 1 sin pi x by 1 plus x square dx is equal to mu into integral 0 to 1 sin pi x dx. So this is equal to mu into 2 by pi because you have evaluated the value. So in this inequality, in the middle position, since mu into 2 by pi is there, you multiply with 2 by pi. So this value is equal to 1 by pi is less than or equal to mu into 2 by pi is less than or equal to 2 by pi. So in this middle position, from this equation we replace with this one. So you have 1 by pi less than or equal to integral 0 to 1 sin pi x by 1 plus x square dx, which is less than or equal to 2 by pi. So this was the conclusion there. So on the whole, if you look at this problem, while attempting it on paper, we should bifurcate the whole procedure into 4 steps. The first part is keeping in mind the statement of first mean value theorem. We have to mention it on paper that what is f, what is G, what is the interval. Both f and g are Riemann integrable and G keeps the same sign. This is part 1 in the solution criteria. Criteria 2, after writing the mean value theorem statement, we should calculate this integral portion using fundamental theorem. Step 3 is mu is lying between infimum and supremum of f, so you have an inequality. And step 4, substituting this value in the middle of the inequality, you will get the required solution. So the total solution is bifurcated into 4 parts like that. Okay? Is it clear to all? Any doubts you have to anyone? Is it comfortable to understand or confusing? After noting, you please tell. I will give 1 or 2 practice problems on this model because it is most important. So do you have any doubt with regard to this approach? What is stated here? All of you? Please say. So are you comfortable in bifurcating the total solution into 4 parts and attempting it one after the other as shown on the board? Right. Then you take one problem as an assignment. I think it is given in the previous year papers. It is very easy to attempt, not at all difficult. I'll give the respective hint also. So the question is, prove that pi square by 9 less than or equal to integral pi by 6 to pi by 2 x by sin x dx is less than or equal to 2 pi square by 9. Just what we did now using the first mean value theorem, you follow the same procedure. From the problem, it is evident that the interval is closure interval pi by 6 and pi by 2. And visually, you have 2 functions appearing there. One function is 1 by sin x and another function is x. Now the question is, which one will be taken as f and which one will be taken as g? Any guesses from anyone? Yes, g is equal to x and f is equal to 1 by sin x, because in the formula you are integrating g. So among 1 by sin x and x is very easy to integrate, right? So you take x is equal to g and f is equal to 1 by sin x and do the same part. Automatically you will get the required inequality. Okay? So you just take that as an assignment. So here I want to conclude our today's discussion. On Monday I want to take some miscellaneous parts under Riemann integrable around half an hour to 45 minutes. Then I conclude Riemann integration concept and I will go with the problems on improper integrals. It is just like seeming to be calculus. Much theory is not there, just problem solving techniques we are going to discuss. Improper integrals we are going to discuss. Okay, so that is my upcoming module. So if anybody has any questions, you can ask. So is it give a brief idea over Riemann integrability to all? So if you go for real analysis, I will say for improper integrals, if you are good enough to follow, 3 classes are there, and for uniform convergence, I want to take 2 classes. So in the next week, the entire concept of real analysis will be finished. That's it. Then that's all for today. We will meet on Monday.